Hello there. Welcome to the Sleep Lab. There is a planet in our cosmic neighborhood that scientists cannot agree exists. It has been confirmed, erased, and reconfirmed. Tonight, we will investigate the ghost. Proxima Centauri C sits 4.2 light-years from Earth. That sounds close on a cosmic scale. But at our fastest spacecraft speed, reaching it takes 18,000 years. It is close and completely unreachable. This planet orbits a red dwarf star. Red dwarfs burn cooler, dimmer, and far longer than our Sun. Proxima Centauri will outlive our solar system by trillions of years. The star is ancient and still just getting started. Proxima C sits beyond what scientists call the snow line. This is the boundary where planetary formation models say large planets cannot grow. Yet here it is, existing in defiance. The formation textbooks do not account for it. Here is the question that will drive this entire investigation. Why does Proxima C appear far brighter than its size allows? Something is reflecting enormous amounts of light. We will not solve this until the final minutes. Hold that thought carefully. In 2016, astronomers discovered Proxima b, a planet inside the habitable zone. The scientific world celebrated a potential Earth neighbor. Then Proxima C was found further out. One star, two planets, two completely different stories. Proxima C takes 5.28 Earth years to complete one orbit. 1 year in this world equals 5 of ours. Imagine aging 1 year while Earth cycles 5 full seasons. Time itself operates on a different ledger out there. In 1995, the Hubble Space Telescope captured data. Nobody analyzed it for Proxima C. The planet wasn't discovered yet. 25 years later, scientists reopened that data. The evidence had been sitting in an archive, unread. The surface temperature of Proxima C is approximately minus 234 degrees Celsius. That is colder than Pluto. No liquid water. No warmth. No conventional chemistry for life as we understand it. This is not a gentle world. Stop. Consider this seriously. If Proxima C should not exist where it does, and our formation models are correct, then either the planet moved, or our models are fundamentally broken. Which answer makes you more uncomfortable? Planetary migration is a real, documented phenomenon. Jupiter in our own solar system likely shifted its orbit billions of years ago. This migration reshaped everything, including conditions that allowed Earth to form. Movement at planetary scale rewrites entire systems. The Very Large Telescope in Chile aimed its SPHERE instrument directly at Proxima C. SPHERE is designed specifically for direct planetary imaging. It found no clear detection. A planet that arguably exists refused to be seen. Scientists then stacked multiple exposures together. Each individual image was corrupted by atmospheric interference. Only by layering them could a faint signal emerge. The planet wasn't captured. It was mathematically reconstructed from noise. A separate telescope, ALMA, detected a bright source near Proxima C's expected position. ALMA reads thermal emissions, not visible light. The source was real, but scientists could not confirm if it was the planet or background interference masquerading as one. Here is the second unresolved mystery. Proxima C does not transit its star from Earth's viewpoint. This means our most reliable detection method is completely unavailable here. How do we find it then? And can we fully trust that discovery? The answer will come at the end. The radial velocity method detected Proxima C. This technique measures tiny wobbles in a star's movement. A planet's gravity tugs its star slightly. That tug creates a measurable Doppler shift in the star's light spectrum. It is forensic astronomy at its finest. But radial velocity has one critical weakness. Stellar activity, flares, surface disturbances can mimic a planet's gravitational signal. Proxima Centauri is a violently active star. Its surface constantly erupts. Separating planet signals from stellar noise is extraordinarily difficult here. In 2022, a research team published a direct challenge. They argued Proxima C's radial velocity signal was not a planet. It was systematic instrumental error, a ghost created by the telescope itself. Suddenly, the planet's entire existence was back in question. This is what makes Proxima C genuinely extraordinary. Most exoplanets, once confirmed, stay confirmed. This one entered a scientific loop of confirmation and erasure. It exists in a state of permanent evidential uncertainty. That is deeply unusual in modern astronomy. Here is a direct challenge to your logic. You trust science because it produces definitive answers. But Proxima C has been confirmed and unconfirmed by equally qualified scientists, using the same data. What does that tell you about certainty itself? Proxima Centauri itself cannot be seen with the naked eye. It sits at magnitude 11.13, far below human visual threshold. Our closest stellar neighbor is invisible without instruments. We live beside something we fundamentally cannot perceive unaided. Early reports mistakenly placed Proxima C inside the habitable zone. Science journalists amplified this error globally. Millions read about a potentially life-friendly neighbor. The correction came quietly. Far fewer people saw it. Misinformation moves faster than data. The actual habitable zone candidate is Proxima b, the inner planet. Proxima C orbits nearly 4 times further from the star. At that distance, stellar warmth becomes negligible. The surface receives roughly the same energy as deep interstellar space. Proxima Centauri launches brutal ultraviolet flares regularly. These flares carry enough radiation to strip planetary atmospheres over geological time. Proxima C, despite its distance, is not immune. Scientists genuinely do not know if any atmosphere survived. Here is the third and deepest mystery in this investigation. If Proxima C is confirmed real, its brightness still cannot be explained by the planet alone. Something is producing excess reflectivity at a scale our instruments weren't designed to process. The answer will arrive later. The leading hypothesis involves a ring system, not rings like Saturn's modest bands. Scientists speculate a structure spanning 5 times Jupiter's entire radius. If accurate, this would be the largest known ring system ever recorded around any planet anywhere. Ring systems form from collisions, moons shattered by impacts, debris captured gravitationally. But Proxima C is old, ancient even. Old planets shed their rings over time through gravitational dissipation. Retaining rings this massive across billions of years defies standard ring dynamics entirely. One alternative hypothesis suggests captured debris from a recent collision. A massive impact event could theoretically regenerate a ring structure, but no collision evidence has been detected. This explanation requires an unobserved catastrophic event. Science does not favor invisible causes. There is another candidate explanation: a system of captured exomoons. Large moons reflecting starlight collectively could mimic ring brightness signatures. Exomoon detection remains at the absolute frontier of observational astronomy. We have confirmed 0 exomoons anywhere with certainty. Pause your assumptions entirely. 3 separate explanations exist for Proxima C's brightness: rings, exomoons, or instrumental error. All 3 are scientifically legitimate. All 3 remain unproven. Science is not always a locked door with one key. Sometimes it is a corridor with no visible end. The contrast paradox is genuinely counterintuitive. Proxima Centauri's extreme dimness, normally a limitation, actually helps direct imaging attempts. A faint star creates less glare interference. Planets around dim stars are paradoxically easier to photograph than those around bright ones. The Gaia Space Telescope has been quietly monitoring Proxima Centauri's positional drift. Gaia measures stellar movement at microarc-second precision, a unit so small it has no human-scale equivalent. If Proxima C exists, Gaia's astrometric data should eventually settle this permanently. Astrometry, measuring precise stellar position shifts, is the third independent detection method being applied here. Radial velocity found the signal. Direct imaging captured the brightness anomaly. Astrometry now acts as the forensic tiebreaker. 3 methods, 1 unresolved verdict. Future telescopes change this equation significantly. The extremely large telescope, currently under construction in Chile, will have a primary mirror spanning 39 meters. Its resolving power will make current instruments look approximate. Proxima C will have nowhere left to hide. We return now to the unresolved question. Why is Proxima C impossibly bright? After exhaustive analysis, the ring hypothesis remains the strongest candidate. The rings would need to span roughly twice Saturn's visible diameter. No confirmed mechanism explains their survival, but no data eliminates them either. Earlier, I asked how we found a planet that cannot transit its star. The answer is radial velocity forensics, measuring gravitational tug through spectral Doppler shifting. But the 2022 challenge exposed this method's vulnerability to stellar noise contamination. Current consensus: the signal is real, but not yet bulletproof. The deepest mystery resolved here: excess brightness with no confirmed source. Here is the current scientific position. The planet likely exists. The brightness likely requires a ring structure or exomoon cluster. Neither is confirmed. Proxima C remains the most scientifically contested planet in our immediate stellar neighborhood. What Proxima C has already accomplished matters independently of its confirmation status. It forced a revision of planetary formation models. It demonstrated radial velocity's limitations around active stars. It revealed how much observational bias shapes what we classify as real. One contested planet, multiple scientific corrections. The ghost planet designation is no longer merely dramatic language. In peer-reviewed literature, Proxima C occupies a genuinely ambiguous evidential category. It sits between confirmed and theoretical, a classification that almost never persists this long in modern astronomy. Science named it. Science cannot yet fully claim it. If this investigation changed how you think about scientific certainty, please subscribe and share it with someone who believes science always has clean answers. The universe does not issue clean answers on demand. Good night from the Sleep Lab.